Welcome to qnawire.
In this question, we are looking at the electrons acting as a wave passing through a single slit. Right. So for the single slit experiment, we know that all the minimums, that is when there are little or no intensity of the wave hitting the screen, is given as a sine theta equals to m lambda, right, where m is the order of this minima, lambda is the wavelength, theta is the angle from the normal, and A is the diffraction slit size, right, or the slit width. So we are looking at the first order because we're looking at a point where, right, the electrons hit closer to the center, right, but it's not hitting at that particular point 20 degrees away. So we're going to assume that 20 degrees is the first order. So given that this is the first order, this will be just lambda. A is the slit size, which is 150 nanometers. Alright. Now what we need is the wavelength of what we get will be the wavelength. And with this wavelength, we should be able to find the speed or the velocity of these electrons as they are passing through the slit. So the wavelength is about 5.13. Using the de Broglie's wavelength formula, P equals to h over lambda, where the momentum, to get the velocity, we just have to divide by the mass of these electrons. This is the mass and the wavelength, which we have calculated. We should get the velocity to be about 1.42 times 10 power 4. Now to find what is the next larger angle at which no electron will hit the screen, well, that will be the second order that we want to find. We substitute in the values again. This is the slit size multiplied by sine theta. Right, we don't know what's the angle now, but we know that we want the second order, and we know the wavelength. It's 5.13. So from this, we divide the factor over, then we take the sine inverse or arc sine of this right side, of the right side factor, to get our theta. Should be around 43.2 degrees. And since it can occur on either side of the maxima, or of the central maximum, right, so the angle can be plus or minus 43.2 degrees.